So we're going to do that here in a minute. But I do want to see if anybody else, there were some good questions during office hours. Let me know if you have any questions. So let me show you where these sheets are. So let me become a student here real quick. I just added a worksheet in 2 worksheets. This is the first one I want to talk about. So tonight, what I want to do is I want to focus on basically through 5.4, because what's the quiz going to be next Tuesday? It's going to be through 5.4. It's crazy. 5.5 is where we start working on the list of possible roots, and we started talking about, remember the upper bounds and the lower bound we talked a little bit about yesterday? Remember that, you guys? And the list of roots that I have to use synthetic division and see which ones work and which ones don't. Are you guys, anybody not with me with what I just said? I want to crawl through the camera and actually look at a lot of guys and see. Look at me. Let me see your eyes. All right. So if we look at this sheet right here, if there's no questions, we're just going to jump right into it. What I've done here is I've created a couple of problems. So I think let's do this. Let's do the first page together. Is everybody able to go get this sucker up on the canvas, up on the internet? So let me show you again where it is. If you go to modules, it's under unit 5. And it's called factoring, roots, multiplicities, and graphing. Okay, so let's get that bad boy. All right, so let me open this up in a better way so I can work with it better. Oh, I always forget to do this ahead of time. Too bad. Let's see, here we go. All right, let me do my technology switch.
Bluetooth mode.
Yeah.
Bluetooth connected.
All right. Oh. There we go. Come on, come here. All right. All right, so let's do this one together, and then I'm going to let you guys work on the back by yourselves. So you guys help me out. And by the way, if anybody just came in, well, let's see. I don't know. I was asking for homework questions, but it's too late for that. Here we go. Somebody tell me what the end behavior is of this sucker here. What's the end behavior? It's going to go like a what? This is pretty easy, this one, because it's not factored yet.
Go up.
Yeah. Is that always the one that's here? What is it? It's the one that's
The most degree.
the biggest. Exactly. So you got to be careful, because I could give you one that's out of order. You know me. You should probably know me a little bit by now. I might give you one that's out of order just because I'm an asshole. All right. And what does that translate into in terms of end behavior?
Go up.
Turns.
Yeah, you're thinking ahead a little bit. You're thinking multiplicity. So end
Oh,
behavior
yeah,
will be
both
up
of
on.
them up. Yep.
I like it. And why do we keep the middle blank? Because the middle's where all the wobble shit happens. But I know whatever wobble shit's going to happen, it eventually has to go up on both sides. That's the idea. All right. I like it. Sorry. Factor. All right. So how do I factor this thing? Let me write it down here. Can somebody see something I could do right away to start factoring this thing?
Factor by x squared.
Yeah, I can take an x squared out. I like it. So don't forget about GCF. People sometimes forget about GCF and they do some weird shit. Always look for GCF first. And then, of course, the inside's relatively easy, right? Anybody got that? It's your time to shine. Do it. Take it.
Plus 2 minus 5.
Nope. Other way.
X plus 5 minus 2.
Plus
Oh.
2 minus
Because the big one's got to be positive, so the middle term ends up positive. I like it. Cool. I like it. So what are the zeros?
Minus 5 and plus 2.
Oh, interesting.
0.
Yes. All right. So I could, a collection of zeros, it's fine to not write them as points because they're not intercepts that I'm asking. It's just to find the zeros. So the zeros are 0, -5, and 2. I love it. Why is the y-intercept easy? The way that the function's given to me. And it's easy, especially because of something else. Sorry.
Because of the x squared in the front.
Yeah, yeah. If x is 0, y 0. So 0, 0. If one 0 is 0, then the y-intercept is 0, 0. I have no idea if you guys are with me or not. If an x-intercept is 0, 0, that's got to also be the y-intercept. Okay, I like it. Why is there always only one y-intercept? I think I already asked you guys that. Because if there were two, it would not be a. If there were
Function.
two y-intercepts. Sorry?
Function.
Function. It wouldn't be a function if there were two y-intercepts. Kick ass. What's the multiplicity at each root?
4, 3, 2.
What happened? No. What's going on? What's the multiplicity for the root 0? Where did it come from?
2.
So that's got a multiplicity of 2. And the multiplicity for these guys are both
1.
1. I like it. They both came from a power of 1. All right, let me make sure. Does everybody understand that? Are you guys with me? Do you guys see why 0 has a multiplicity of 2? It came from a term that was to a second degree. That's it. Another way to look at that is 0 shows up twice because this is x times x. So there's two zeros. There's only one -5 and one 2. I like it. What does that mean it's going to do? Now it's your turn to shine, somebody who said that too early. What's it going to get? What's it going to do? What's the graph going to do when it hits 0?
Turn
Yeah, turn. And of course, the other two, it's going to go
through.
through. And you can spell through correctly if you want to. It won't hold it against you. All right. So this kind of problem is the kind of problem I will give you this problem, not this exact problem, but a problem like this on the quiz on Tuesday, right? You have to be able to do all these things. So let's see what we got. We got, you can do it, Jeff. We got 0, 0, -5, 0, 2, 0. It turns here. Holy crap, Jeff, what language is that? I don't know. Get out of there. What year is it? All right. Turn. Through. What else we know? So that kind of sucks. We don't really have a y-intercept because it's sort of got sucked into the x-intercept at the origin. That kind of sucks. So all I know right now, so it's sort of acceptable. Yeah, let's go ahead and just do this one by ones. I kind of like to have, I think I told you guys, it's normally a good idea to go out one more than your furthest root, but oh well, this is fine. There's a 0, there's a 0, there's a 0. So not having the y-intercept kind of sucks because it kind of gave me a natural feel for how far up and down it was going to go. So I've just got to use a couple more points. Does somebody know? Can somebody pick a good? See how I say right here? A few more points. When I say a few, in fact, on the quiz, I will be much more specific about exactly how many points you can use at most. Because I'll have people make this huge table of points. And I'm like, no. That just defeats the whole purpose. All right. So what's a smart point input to use here?
-3.
-3. I love it. What's one more for sure?
1.
1. Kick ass. Do you guys agree? Do you guys see why those are good choices? Did somebody have a different choice? You're all like, dude, you like those. Why would I have a different choice? Well, I mean, I would have accepted -2 or -4, but -3 is right in the middle of everything. That's fine. -2 would have been fine too, somewhere in there. So it's in between the intercepts because that's the region where you have no information. That kind of makes sense. So let's see, what the hell is f of -3? I like to put it into the factored form right up here. F of -3 would be 9 times 2 times -5. Do you guys see that? 9 times 2 times -5. Is that cool? You guys okay out there? Or you could put it in here. I don't give a shit because it's the same thing. These are the same function, right? It's just a little quicker to do this. So there I get -90. Oh, shit. What's f of 1? That will be 1 times 6 times -1. Well, that's nice. Thank you, 1. You're reasonable. All right. Maybe. I'm just collecting information for myself. At the same time, I don't want to make it so you give yourself like too much information. I want to get us away from trying to make a whole table of values. So let's see. What kind of scale should I use on my y-axis then? Who's got a good tick mark scale for this? Anybody? What's a good scale to use here? Should I go by 3s?
20.
Probably.
20. I like 20. 20 is exactly 20, 40, 60, 80, 100. You see how that puts 90 right on the lower edge? It's perfect. So then f of -3 is -90. Okay, good. So now I can put that right there. Bam. And then I know, oh, got it. And then I know f of 1 is -6. So it's like, this is 10. So -6 is like right there. Okay. Neato. So now we hope to God that this matches with end behavior and all this turn and through shit, right? You kind of catch mistakes you make because everything's got to jive. So where's the end behavior begin? Up here, right? So that gets me started. So I'm going to start up here, come down. What am I going to do at -5? You can see 2 reasons why this is true.
Go through.
Go through, and it makes sense. I got to go through so I can make it down to this point. So everything's is cohesing so far, right? I don't know what good word to use. Jive makes it sound like I'm trying too hard. Hello, fellow young people. All right. So here it comes. There's the end behavior. I go through there. Oh, crap. This thing is not, this is weird. All right. And then I go through, and then I'm going to pretend like that's the turning point. I have no idea, but that's the best information I have. I've got to come back up to this intercept. And what do I do at 0? What do I do at 0?
Turn.
Turn. And why? And thank God I do, right? Because I got a freaking another point right here that I got to go through. I'm going to pretend like that's the minimum. I don't know if it is, but it's the best information I've got. And I've just screwed this up. And then I'm going to go through 2, and then up it goes. Yeehaw. So it looks like a reverse Texas. I don't know. It looks like I don't know what that is. All right. And again,
Why did you start in the top left quadrant?
this guy tells me how to start things off. Now, be honest, if you want to, you can start over there, but it doesn't really matter. This tells me how to start things off. And then what it does at each root tells me how to keep going. And I keep an eye on the couple of points just to make sure that it's all coming together. If I was supposed to turn at -5 and there was a point down here, I'm like, okay, I have made a mistake.
So the function being even or odd determines where it starts, but also if it's negative.
Now, have we looked at symmetry on this problem? Did I even talk about symmetry? No. Oh, but I see what you mean. You mean just you don't mean symmetry necessarily. Yeah, the end behavior is determined by the degree of the polynomial, right?
Sure. So what if, I guess it can't be negative, but the coefficient can be negative.
Yeah, the coefficient could be negative, in which case it would have been down here and down there, right?
Okay.
Okay, I like it. All right, so now I want you guys, any questions on this one? Now is when I would do it in my calculator, because if I do it before I do this work, I have screwed myself up. I'm never gonna get that out of my head. You only make changes, you go find your work if your graph is really off, and you go find the work where you made a mistake, right? If you're running out of time and you can't see what you did wrong, leave the graph as it is. I will not take off. All right, let me see how to say this. I will take off more points if your graph does not match your work. Do you understand? You will get points for an incorrect graph as long as it actually matches your work. Because that's what I'm trying to get you guys to learn is how does what I've done work-wise translate graphically? Okay, I like it. So I'm much less interested in a perfect graph if you've made mistakes in your work, especially. Okay, that's enough of that. So you guys do this one. You guys do this one. Can somebody give everybody a little hint as to what method of factoring you should use for part B?
Grouping?
Yes, I love it. All right, go for it. Be really careful. Jordan pointed this out a minute ago. Be really careful about that negative sign there. All right. I'll sit here and hope. I'm going to put a note up here for myself. I'm going to talk to you guys about something. I'm going to sort of catch up to you guys a little bit. All right, let's talk about B. I'm hoping most of you guys have tried B out. If you mess up on B, you're gonna die on C. So I'll tell you this. Normally on a test or a quiz, if I give you a function like this, on this step, I'll say, show that this factors to be this, and I'll give you the factored form. So if you aren't able to factor it, you're at least able to do the rest of the problem. Does that make sense? No? All right. We'll find out when you get your quiz. So what did somebody do first to factor this thing?
Take out negative x squared from the first half.
Okay, sure. So take out a negative x squared from the first two. I like it. So then what'd you get?
X minus 3.
I like it. So you could have taken a negative out from the whole thing first. I kind of prefer this way. This is fine. Take a negative x squared out. I like it. Or you could have taken an x squared out and left the signs reversed. That would work also.
That's what I did.
Oh, you took a positive x squared out?
Yes.
All right, we'll do that over here. So then in here, you got negative x plus 3, right?
Yes.
Okay, I like it. So let's see. Going back to this first one. What do I have to take out of the next group?
9.
3.
Yeah, you got to take a 9 out. And then you're left with an x minus 3. See, these match now. Now, here's what makes this way a little harder. What do I have to take out for this other way? Because if I take a 9 out, that's going to leave a positive x and a negative 3. But really, the main thing about grouping is you're not doing it right unless the second little dude is the same as the first little dude. Because if they're not the same, you can't keep going. So I've got to change the sign. Sorry?
Taking out a negative 9.
Got to take a negative 9 out. Then it becomes negative x plus 3. Now these guys are the same. So that's why it's better to get the negative out of the way in the first place. So you don't run into weird shit like that. So if I keep going this first way, I'll get, oh, I got a chat. I can't handle it. Oh, good. Okay. So I can take an x minus 3 out. And then I'm going to write this as 9 minus x squared. Is anyone going to freak out if I do that? All right. And over here, if I go over here, I would get negative x plus 3 times x squared minus 9. All right. So I sort of got the same problem both ways here. So here I get x minus 3. And then this is difference of squares, right? What do you get here and here?
3 minus 6 and 3 plus 6.
I love it. And if I do this one, I'll get x minus 3 and x plus 3. Now, is this written in the best form?
No.
Nope.
No. So this is where they're both going to come together. If I take a negative out of this, then I'm going to have 2 of these, right? If I take a negative out, I'll have 2 of these and 1 of these. So over here, if I take a negative out of this, it becomes another one of these. Is everybody with me? That's why if you took the negative out in the very beginning, you wouldn't have to do something weird like that. The negative would have just come down all the way with you. It would have been, yeah, that works fine also. Is everybody with me? So now I can see multiplicities better. I can see my n behavior again, right? Negative x cubed. Okay, I like it. I like it. Well, shit, I've left myself no room. What are the, I'm gonna erase this other way here. All right, so what are the zeros? Anybody?
Minus 3.
Zeros?
3.
Sorry? 3 and?
Minus
-3.
Yeah, 3 and -3. And what's the blah, 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 blah? 3 and -3. There you go, Jeff. And what's the y-intercept?
minus 27.
0, -27. Love it. Kick ass. What's it do at 3? What's the multiplicity at 3?
2.
Yeah, 3's got 2. So what's it going to do at 3? It's going to
It's gonna turn.
turn, kick ass, and the multiplicity here is 1, so it's going to go through. I love it. So let me try to accumulate everything we know here. Oh, I got to stop. You guys, I meant to only do part B. All right, keep going. Now you guys do part D. You guys put it all together for me. I know it's hard to understand, but I get into a problem and I want to I want to see what it's going to be. What the heck, Jeff? I have no idea. All right. What are you guys using for you should use probably 2 more points. Anybody? What would be good to figure out to use as additional points?
-1.
Sure. -1 and?
One.
1, sure. Or you can use -2 and 2 for some combination. I like it. You could even use -1.5. I don't know why you would, but you could.
I have a question.
Yeah.
If I use numbers that are like easier for me to graph, because if I have because I used 1 and then I got -16, but then I used 2 and I got -5. So if I use 2, is that wrong or is that
No, it's not
okay?
wrong. It's not wrong. No, it's not wrong. Because everybody, depending on the point you use, these extra points, you will either just luckily find the real turning point or not. And or get closer to it. Nobody's going to find it by hand unless we got lucky the other day that it was a whole number. Does that make sense?
Yes.
So I said you could use one or two. One of them's going to be smaller than the other one. You're going to assume that's the turning point, maybe. So that's fine, right?
Okay.
That's fine. Yeah. Let me see. So yeah, you could do that behind the scenes. Pick the one that kind of comes out nicer. I forgot what I was doing. Oh yeah. Supposed to be negative. Oh, 4 times 4. Okay. So yours is going to come out a little different than mine. So it looks like, so your scale might be even different, but we still have to get that y-intercept, so maybe not that much. Yeah, all right. I don't know. What did somebody use for their y-axis scale? What did you guys use for your y-axis scale? Anybody?
Ten.
Say again?
10.
10, 10's okay. It's a little big.
I used
I'm gonna 5, 5, 10, 15, 20, 25. It's not going to make, yeah, I don't know if you got this point or even that point. It's going to be off your graph, right? So I'm going to use 8 just because. What have I done? That's good, Jeff. Let's see. What have I done? Okay. So now I can plot my 0, negative 27. It's going to go about right there. Okay, okay. I appreciate you guys. This is not the most exciting thing in the world. I know. 3s would definitely be too small. You never get up to 27 on this little graph. All right, and now I can plot my other points. -1, negative 32. Bam. 1, negative 16. Bam. My end behavior starts up here. And then I go through -3. So I start up here. I almost feel like this would be easier with the mouse. I don't know. I don't know what to do here. This is weird. All right, go through. I'm going to make it down there. And then I'm going to go through here. I got to do some weird things just because. And then what do I do at 3?
Form.
Yeah, so I kind of did this wrong, but too bad for me. A turn. All right, so mine looks really bad, but this would still be acceptable. Probably didn't have as much wobbliness in it, but oh well. So, you know, it would be sort of acceptable to do like f of -4 or f of 4 just to see how quickly it rises. But normally once it gets out of the wobbliness, out of this section, it goes up and down pretty quickly. It kind of grows in, pretty quickly in both directions. Okay, maybe. That's not that bad, is it? And I don't give you a problem and just say, do all the steps. No, I say this, I say this, I say this, and then I say, okay, put it all together. Right. All right, so hopefully that wasn't horrible. So now let's shift gears. So that's definitely one of the problems I could put on this next quiz for sure. It's got everything basically that's happening from the first part of chapter 5. So let's talk about section 5.5, right? That's where we get into long division and synthetic division. So here is the other handout. So right underneath where you just got this handout, this one's got a lot of shit on it. Let's talk about this. We got to build our way up to this. So let me see if you guys remember. Remember last time we talked about upper bound of stuff? Let me see. So let me actually, all right, we actually talked about a couple things. Here's one kind of nifty thing. Descartes, I think he's like that, there. Rule of signs. Shua. Right, not astrology. So this is kind of neat. I kind of touched on this a little bit yesterday. Anybody heard this guy's name before? Descartes?
A few times.
Few times. I like it.
Oh yeah, it's my first time.
First time. Okay, I like it. Long time listener, first time caller. All right. Does anyone know the most famous thing Descartes has done? We actually use his name. This is a weird thing. Let me ask you this way. What is the technical name for the XY plane? Does anyone know? Starts with a C. I'm kind of worried what I'm going to get. I'll tell you what it is. It's a load of crap. It's called the Cartesian coordinate system. Blah, blah, blah. Cartesian, Descartes, we stole it from him because he supposedly, the urban legend is, he was sick on his bed, staring at a ceiling, and he saw a little fly walking around, and he imagined how to tell the trajectory of the fly walking around with the XY grid. And then he did the work, and there it is. And everybody's like, yeah, you were sick when you did this? Yeah, okay. All right. So that's that. There's some legends like that in math. You would never make a movie out of it, but still, it's there. Descartes' rule of signs is kind of a little weird. Here's the extreme example. See if you guys remember what we said about this. What's got to be true about things that make this zero? We talked about this yesterday. If I'm going to plug a value in for x and make this equal 0, can somebody tell me what has to be true about that number? Or what can't be true about the number?
Bigger than
It can't.
2.
Neat. I got two there you go. Somebody beat you to it in the chat. Can't be positive. If x is 0, the answer is 2. If x is anything bigger than 0, it only becomes bigger, right? Because everything else adds to 2. Adds on top of 2. You understand what I'm saying? A little bit. So if there is any x value that makes this thing 0, it has to be negative so that this and this are negative. So there's a chance for them to cancel each other out. Does everybody get that? So if I am given a polynomial where everything in it is positive, I can throw out all of my positive roots out of my list that we make. Are you guys with me? My list immediately is cut in half. I'll try. I really want you guys to get this. What part is not understood? Somebody's asking me. So what is P of 0 here? What is P of 0?
Plus
What do I give
2.
2. So what would P of anything bigger than 0, any positive number? You could do it, Jeff. Just write the word. There it is. If I put any positive number in here, won't it be bigger than 2? Because I'm going to add.
At
So
least.
So is there any positive number that would make this become 0? No. Right? Do you guys get that? Does it matter that this was a 7? Do you understand that question? All that matters is that it's positive. Doesn't matter that was an 8. Doesn't matter that was a 2. Doesn't matter that was, no. If they're all positive, this idea stays the same. Okay, I like it. All right. Now, here's the other side of the coin, though. So what would make it so that no negative numbers work? Not they're all negative. No, that doesn't make any sense, to be honest. Watch this. So this one is no possible. You can make it, there's an S, positive roots. All right. So what about if I had a polynomial that looked like this? Let me make different numbers just to be different. There. All right. Neato. Imagine I plug any negative value if I plug a negative number in, everybody, any negative number, what's going to happen? What will this become? What sign would this be?
Negative sign?
Right. What's a negative number to the 4th power? It would become, I think somebody
Positive.
said positive. Are you with me? What about this? That would be negative, right? You guys with me? Real quick, a little side note, just in case you forgot. A negative number to an even power is positive. A negative number to an odd power is negative. Because if I have an odd number of negatives, 2 kill each other, and the last dude's like, aha, right? So any odd number of negatives, a pair kills each other. He's still left alive. Any even number, everybody pairs up. Oh, and they kill each other. Oh, so it took a turn. All right. Positive, positive, positive. Positive, positive. He's got the same problem this guy the other way. He's got the same problem he had the other way. So somehow, now, so look at this. This is neat. So watch this. This is what Descartes said. If I take the polynomial and I put a negative x in like that, and the result would be this. Is everybody with me? This is basically what we just said. All right. So these are specific outcomes of Descartes' actual rule of signs. So I think maybe I've built this up. So let's here we go. This is kind of neat. I'm gonna erase this. We're in the right mindset now. So if I was given this polynomial, to see that it has no negative, no possible negative roots, put that together in the right grammar, I'd have to put a negative x in to see that it has none. So hold on, just wait. I'm going to erase all this and let's make this more official. All right. All right, here we go. You ready? So here's where things get a little bit more interesting. If I'm given a polynomial, the number of positive, a possible, there you go, Jeff, positive real roots, stay there, is equal to, oh God, oh, you're gonna love this shit, or less than by an even number. Oh man, all right, just stay with me, you gotta trust me. If given a polynomial, the number of possible positive real roots is equal to, this we'll talk about in a minute, or less than by an even number, the number of sign changes in P of X. So for example, if I'm given this polynomial here, it doesn't matter, Jeff, you could have done it. How many sign changes do you see as you go through it? 1, 2, 3. You guys with me? That's what it means by number of sign changes. So how many possible positive real roots? Oh God. How many possible positive real roots? 3 or 1. Okay, let me talk about this. This is exciting for me. I've never actually fully directly talked about this, except a little bit weird ways later. I'm going to try to talk about it right now. Somebody well, all right. What should mostly freak you out right now is what the shit? Why do I do 3? I see 3, but why do I do minus an even number, -2? Why do I do that, Jeff? Why? Okay, let's talk about that directly. And then we'll talk about the negative roots, okay? All right, maybe. All right, I need some room. Get out here. So watch this. This is kind of cool. I like this. So here, let's say, did I have an actual example? Yeah, I did. I have an actual example. I'm so excited. Because I normally suck at putting things together. So it almost doesn't matter what the polynomial is, but if I had this, yeah, is that right? Yeah, okay, I like it. If I had this, it actually comes out to be, so this is bad. If you turn this into me, this would suck, but just for right now, it's fine. This would turn out to be this. All right. I like it. Okay. Oh, I should have started with that. Why didn't I start with that? Let me see. Oh, it doesn't matter. So I want you to see what's the multiplicity on this? What's happening here? What's the multiplicity here?
Turns and that point.
It turns, so what's the multiplicity? Especially
2.
considering it's, say again?
Even.
Even, it's 2, because I know there's a degree 3 total, right? I don't know if you guys are with me. Real quick, it's a third power. There must be 3 zeros. Do you guys see the 3 zeros? What are the 3 zeros of this function? 1.
3.
3. And 3. All right, so we just don't normally list it twice, do we? We call it multiplicity 2 instead of listing it twice, just so we feel less insane. Who's coming? Billy and Bob. Oh yeah, Bob's coming. Oh yeah, Bob said he'd go. You feeling all right, Jeff? So we normally don't list it twice, but that's actually what's going on. There are 3 roots. There has to be. Fundamental theorem of algebra. Degree of the polynomial equals the number of roots. Period. All right, now watch what happens. This is so cool. All right, this is a little bit, all right, I really want you guys to be with me. Look at, what if I do this to this function? What if I do this? Oh, I love this shit. I really hope you guys are at least tolerant of it. You ready? This is almost the same polynomial that I'm going to put here. How are these two different? How are these two polynomials different? You can do it.
Y
What's the
intercept.
only difference? Say again?
Y intercept.
Oh, the y-intercept. Okay. The y-intercept. You're right. The y-intercept is different. Why is the y-intercept different? Because this is this one taken down by 6. Do you guys see that? Isn't it translated down 6? Isn't that 6 less than this? If this is p of x, isn't this p of x minus 6? Yes? Do you guys see that? What do you get when you subtract 6 from this? Don't you get that? All right, I really want you with me. So graphically then, wouldn't that just do this? This would go, this is getting weird, Jeff, I know.
basically it would just take this down, wouldn't it? Do you guys see that? So this would come down and it would have the two roots. I don't know how can I do this well enough? I have no idea how tall this thing is. All right, it doesn't matter. So this would go down to negative 15. This is the part I didn't really do. I'm trying to do it on the fly. What am I trying to say? So this thing would go like that. This would come down. So it would actually have two more roots. It'd have like two distinct roots instead of one of them repeating twice. Okay. That's the part I didn't really do because I wasn't sure I wanted to do that. So maybe I shouldn't have done that. All right. So let me do something more interesting here. Here comes the part about why. All right. Let me build my way up there. So what about this? So like that. What about this?
I'd be moving it upwards.
Yeah. By how much?
10.
10. So now it's here for the y-intercept, right? So now it comes like this. So it's still going to come up through the y-intercept. And what's going to happen over here? This is up 10, right? So this is now going to be 10. Let me see if I can kind of roughly get this idea. So it's going to go like that. So how many real roots does this have? I really want, is everybody with me? That was just barely touching. If I move it up at all, I moved it up 10. If I move it up at all, it loses those two roots. So, I mean, how many roots does it have? One.
One.
Yes.
How did the number of roots went down by 2? Did it? It was either 3 real roots, 1, 2, 3, or 1. It went down by 2. That's going to happen every time. If you pick it up, it's going to lose 2 at a time. All right. Maybe. Oh, that's what I was concerned about, wasn't it? I was being stupid over here earlier. All right. There was a point I was going to make that I could have made and I forgot. It doesn't matter, Jeff. You're fine. Okay. This is more than I've done with this before. So, showing you another example. If I have this, let's see. Let's do this. All right. Negative x to the 5th plus 2x to the 4th plus 3x to the 3rd minus 2x squared plus x plus 1. How many possible positive roots, real roots, are there? How many sign changes are there? 1, 2, 3. Oh, that's exciting, Jeff. So how many possible positive real roots are there? 3 or
1.
1. Yay. So if I had, real quick, if I had x6 minus x5 plus x4 minus x3 plus x2 minus x plus 1. That's 1, 2, 3, 4, 5, 6. So it's 6 or 4 or 2 or 0. You of course stop when the next step would go negative because that doesn't make any sense. Sign changes. What's the sign of the first term? Is this positive or negative?
Positive.
Positive. As I move, did the sign change? So I count that. It changed once. Oh, it changed again twice. Oh, it changed again 3 times. Do you guys see? Somebody's texting me. It's private messaging me. Up here, it was negative. Now it's positive. That's 1 sign change. It stayed positive. I didn't count that. Oh, now it becomes negative. That's 2 sign changes. Now it's positive. That's 3 sign changes, and it stayed positive. Okay. Does everybody get that? That's what I mean by sign changes. Okay. So what about negative roots? I do everything I just did, but I do it with p of negative x. So if it's this to start with, what is p of negative x? I really want you guys to understand how this is so quick. Which terms will change signs? The terms that have what kind of powers?
Even?
No.
Oh, because it's opposite. So the odd ones.
The odd ones always have two kill each other and the other guy's like, haha. So these guys, when I plug a negative in, it'll stay negative and that'll change the sign. So this stays the same, this changes. This stays the same, this changes. This stays the same. If you don't trust me, put a negative x in, put a negative x in, and then do all the work, and then finally get to where I just got. Okay. Sorry. These shortcuts aren't difficult to understand. They're built on the basic ways how negatives interact with powers. All right.
For the homework or tests, do you have to show the work for that? Because you didn't, like, can you just do the shortcut like you did, or do you have to show the work?
Wait. Oh yeah, yeah, this is fine. This is the work. So you would do the first one real quick before we go away. How many possible positive roots? Possible positive roots. That would be one. Do you guys see that? It only changed sign once. Now I could do, when I put a negative x in, now I can do possible negative roots. So I do the exact same thing, but just with what it looks like when I do this. So how many times does the sign change? Once, twice, 3 times. So there's how many negative roots possibly?
3 or 1.
3 or 1. Kick ass. Cool. And I forgot to point out that when I had this sucker like this, there's a real root. What are the other 2 roots? What's true about the other 2 roots in this case? They can't be real because I lost my 2 real roots, so they must be
Imaginary.
yeah, imaginary, complex. I like it. I like it. Hey, Mikey. Okay. So let's do this. All right. Oh, that's Descartes. That's Descartes. Let's talk about upper and lower bounds. And then oh yeah, I think that'll be it for the day. But once we talk about upper lower bounds, we'll probably stop. Right. Oh, and before I forget, the note that I put on there. So I had a dental emergency this morning, so I had to cancel my class this morning. They got me to a good place, right? I hate stuff to deal with the teeth. My teeth are normally fine. If you're a human, you live long enough, shit's going to happen. So next Tuesday, we're not going to have class because I had to schedule a follow-up appointment to go in and have more stuff done. So that's fantastic. So you guys get the day off and you don't have to think about me sitting
Isn't that
there.
the-
You said
quiz
you said
day?
next Tuesday.
Tuesday, yeah. So the quiz will still happen. I'll still have office hours, I think. Yes. I'll still have office hours on Tuesday. I just won't be in class. And the quiz doesn't happen during class anyway. So I'm just going to open the quiz up that afternoon. You guys
Will we
know
be
what-
going over the quiz on Monday then?
Of course.
Or prepping?
You can bring questions whenever.
Cool.
Okay. And everybody remember my Tuesday and Thursday extra office hours. So that's still going to happen Tuesday because my appointment's not till 3. But I'm going to be in the chair for a couple hours. And I probably won't feel like talking after that. And you're all like, that's fine, Jeff. You can stop talking anytime you want to. All right. So last thing. I'll remind you guys next week that that's going to be a holiday for you guys. Celebrate Jeff's horrible teeth. All right. So bounds. Upper and lower. The book actually doesn't talk about these, which doesn't make sense to me because they're actually slightly more useful than Descartes is. So we already talked about the idea of an upper bound. An upper bound is if I synthetically divide something and the answer comes out all positive, then that is an upper bound. So if my list looked like 1, 2, 3, 5, 8, I don't even know, and I get all positives, I can say, and see how it wasn't 0. So I can throw a positive 3 out. I can throw out 5, 8, 10, because that is an upper bound for the answer. Now the negatives would still be here, right? So the negative would still have a -1, -2, -3, -5, -8, -10. I have no idea where that list came from, but it doesn't matter. All right. I don't know if you guys are really with me. On the little handout that I have up there, it kind of goes back over this definition. Weird. Sound like somebody tried to get my door. That's exciting. Sure, why not? All right. So what about lower bound? Lower bound, and this goes right along with Descartes, because the reasoning behind why this is true is intimately related with Descartes' rule. So watch how this sounds very familiar. If I divide something by a negative something, and my answer comes out to be alternating signs, right? Sort of goes along with the idea that when I'm talking about negative, it's all about alternating signs. I don't know if you guys are with me or not. This means that that is a lower bound. Then you found a lower bound. I'm a poet and didn't realize it. All right. So there is a worksheet up on Canvas right now. I think, I mean, we actually do have time. I don't know why I thought that was going to take forever. I kind of feel bad about doing this, but I'm going to do it. Let's take a look real quick. We're not going to do it right now because I kind of told you it was over, but let's just look at this real quick. You're like, whatever, Jeff, you're the freaking teacher. Just do something. All right. Geez, calm down, imaginary student I'm talking to. All right, let me see. Let me pull this up here. Bam. So just real quick, I want to show you where it is. So it's right underneath the one we just did. Narrowing lists of roots down. I forgot to make that. Oh, well, it doesn't matter. I've summarized at the top the idea of an upper bound, the idea of a lower bound, and Descartes' rule of signs. One little thing I always forget, if any of these are 0, they can be either positive or negative in your consideration. I don't know if you guys understand. So if that was a 0 right there, then I still consider this alternating. If there was a 0 on the other one, I would still consider that all positive. I have no idea if you guys are with me. I have no idea. We're going to find out. And then here's Descartes' rule of signs. I tried to summarize that. We'll see how it worked. And there's an example yummy problem there. Look at that. That's yummy. So this is the kind of problem I like to do where I'll say, do this. What's it mean? And it should help you narrow your list down. So next time we'll do that together. On Monday, we'll do this problem together. Okay. So I think that's enough for today. What do you guys think? I think so. I have spoken. That's it. So let me know if you need to hang out afterwards. Otherwise, you're free to go.
I have a totally unrelated question.
Fantastic.
In our early on emails when the class started, we got emails at least I got emails from John Waller. So is it Jeff or John?
This is John. All right. So my name is John Jeffrey Waller. Don't call me Jeffrey because I'm only Jeffrey if I'm in trouble. So the school, I thought hard. I don't know if you guys looked me up on the directory. I'm listed as J. Jeff Waller. That's the best they could do for me. I'm like, I go by Jeff. Can you just put Jeff? I fought hard. After a couple of years of fighting when I first started working here, they changed it to J. Jeff. I'm like, I'll take that as a win. But officially, I'm John on legal issues. So if I see John Waller, I'm like, oh shit, is that jury summons? What is that? If I hear Jeffrey Waller, I'm in trouble. My mom is going to hurt me or something. I get that from my young Jeffrey. Oh shit.
Um,
All right, noted.
no JJ. Don't don't call me JJ. Oh man, that's too bad. You can call me JJ to yourself. I got JJ's class tonight. It's dynamite. All right, guys.
All right, thanks,
Anything
Professor.
else? You're welcome. Anything else, guys? You all good? All right. I'll see y'all next week. Have a good weekend.
Goodbye.
Peace. All right. I'm out of here. Bye, everybody.
Goodbye.